So, welcome to 4.3, Percentages 1. There's two sections on percentages because they're so often used and they're so pervasive everywhere. So, it's just a very special type of rate. When you scale the second quantity or the denominator to 100, and it's called a percentage, right? So, the word percent actually used to be two words, per, which means divide, and the Latin word cent, by 100. Over the years, it's combined into a single word, losing the meaning conveyed by the two words, right? Divide by 100. That is a percent. A percent's a ratio with the second quantity that's scaled to 100, so it's some number over 100. And the amount of the first quantity is said to be X percent of the second quantity. The second quantity is referred to as the base, right? When encountering a percentage, one should always ask a percentage of what, meaning what is the base, the unit, right? The unit of the base, of the bottom number. Percentages are sometimes referred to as rates because they are per 100. With interest rate, which would be section 4.5 would be interest rates. The word percent originally was two words, right? So we went over that. So let's dive into some problems with percentages. So 411A is our first problem that you're responsible for. So it says you took out a payday loan for $350. 1 month later, you paid back the balance, which the $350 is the balance, and $87.50 in interest. What was your monthly interest rate? What is the APR? The annual percentage rate of this loan. So here's the idea. Interest itself, interest, which is right here, is money. An interest rate is the interest paid divided by the balance owed times 100. It's a percentage. Interest rates given on credit cards or advertised on home loans, etc. APR is the annual percentage rate. So, for example, an interest rate of 7% means that for every $100 you borrow, you pay $7 in interest. So this is the interest, and this is the balance. So I'm going to use a proportion in this one. I'm going to say, okay, I paid $87.50 in interest on a balance of $350. And I just want to scale this to some number over 100. So it's just a proportion. So I'm going to cross multiply, and I'm going to get 8750, put it in your calculator, equals 350 times X. And X is the number that's going to go here. So divide both sides by 350. And go on our calculator and see what we get. And if you do that, you should get 25. So I'm going to put that 25 in for X, so I get 25 over 100. And when we write it as a percentage, we sort of take this to two zeros here and the line and put it up here. So 25% means 25 out of 100. But that was our monthly interest rate, because that's how much we paid in interest rate for that month. To find the annual percentage rate, which is the APR, which is what's on all your credit cards, your student loan, or whatever money that you borrow. I'm going to take that 25%, and I got to do that 12 times because there's 12 months in a year, and I would get how much? I'm going to put that in my calculator, and I get 300%. APR of 300%. Now on a credit card, I don't know, you can get anywhere from maybe 18 to 26% on a credit card. A 15-year mortgage today is about, I'm talking November of 2020, it's about 2.5% APR. So you can see this is an extraordinarily exorbitant interest rate. But that's what you get when you get a payday loan. Okay, example 4.12a right here. It says the ratio of the number of women to the number of men at a community college is 3 to 2. That is men. That would be women. 3 women for every 2 men. Scale the second number, which would be this number, to 100 and interpret as a percentage. So I'm going to do it like this. I could just cross multiply and divide, right? But I recognize that 2 times 50 is 100. So I'm going to get 150 up here. See that? 150 to 100. Now, that's it, right? For every 150 women, there was 100 men. That's the same ratio as this, with the bottom number scaled to 100. Now it says interpret it as a percentage. Well, the only thing I can say is the number of women, I'll just make that number of women, is 150% the number of men. And hopefully that makes sense. When you have, this is called a part-to-part ratio, because if we're to add them together, I get total students. So I really can't talk about students in the percentage. The only thing I can say is what I just said. So 4.13a, it says calculate the percentage of total births for the age groups 20 to 24 and 25 to 29-year-olds. So if you read the book for 4.13, it should make sense, but I'll just go over it in a little detail. So here is all births for 2015. Of those total births, this many births could be attributed to women, or actually girls, 10 to 14. So that made up 0.63% of the total births. So 0.63% is 0.63 over 100, right? So that means for every 100 births, 0.63 of them, or less than 1 out of 100, were attributed to women or girls 10 to 14. So we're going to find this one here, what percentage of total births that is, and this one here, what percentage of total births that is. So for the first one, I'm going to go 851,142. That was births from 20 to 24-year-olds, 20 to 24, over the total births, which was 3,000,000 977,745. And I am going to find the percentage by finding what number out of 100 these births represent. So I'm going to cross multiply, and we get 851,142,00. Whoops. Equals 3977745 times x. Divide both sides by 3977745. 3977745, and divide this side by 3977745, and I'm going to go ahead and put this on my calculator and see what I get. And rounded to the nearest tenth, I get 21.4. I'm going to put that right here, 21.4%. So for women aged 20 to 24, 21.4% of all births they accounted for. Another way to look at that is that for every 100 births, 21.4 of them were from women 20 to 24. So let's erase this. So now I'm going to do 25 to 29-year-olds. So I have the births from 25 to 29-year-olds, 1,152,660, divided by 3,977,745. So what I have is the births attributed to women 25 to 29 over the total amount of births. I'm going to scale the bottom number to 100 to find out what percentage this is of this. Put an X here, and why don't you try cross multiplying and dividing, which is going to be, right, cross multiply and then divide, and see if you can match my answer. So why don't you take some time here, put it on pause, and see if you can get that, and I'll put the answer in. So if you did it correctly, or if I did it correctly, I am getting 28.977. Rounded to the nearest tenth, that would be 29%. So I'll put that in here. And what can I say about that? I can say 29% means 29 out of 100. So the meaning of this rate, which is a percentage, is that every 100 births in the United States in 2015, 29 of them can be attributed to women 25 to 29 years old. And this is just a review, right? We could interpret this, what we just completed, to mean that the number of births of 20 to 24-year-olds, which was that many, was 21.4% of the number of total births. Look at the pie chart. I rounded it to 21.4%. Some pie charts might round it to 21%. And look in the book, and you can see why it's probably, in this case, it's more accurate to round it to 21%. Because it looks like if you don't round it to 21%, to the nearest tenth, for example, then it's possible that this here might show 0%, which is misleading. And down here it might also show 0%, which is misleading. So in this case, a pie chart's best looked at, or the data is best looked at, rounding to the nearest tenth. So in this case, for the 25 to 29-year-olds, we got 29%. So I just want to talk a little bit about equivalency, right? So there was 1,152,660 births attributed to 25 to 29-year-olds out of a total of 3,977,745 total births. So that's total, and that's 25 to 29. So that is equal to 29 out of 100. In the same way that 1/2 is equal to 4/8. They're equivalent, right? It's just another way of talking about it. You get your mind around this, and it's easier to understand what part of the total births can be attributed to 25 to 29-year-olds. So it's rescaled. So that was 29% of the number of total births. And it would probably it's probably rounded in the pie chart to that too. Now the only thing I want to talk about pie charts is that if you take all the births, like there's the 14-year-olds, there's the 15 to 19, etc., and all the percentages in a pie chart, if you add them together, you're going to get 100%. Because it's the parts of the whole, right? And that's what we use pie charts for. Parts, the parts of the whole. Yes, and this whole task that we did is a whole lot easier on a spreadsheet. So I'm going to spend a little bit of time with this to explain it, because you'll see a lot of these types of questions. So 4.14a, it says, after the discount, your mountain bike costs $420. If the sales tax is 8%, determine the amount you pay in sales tax and the total amount you pay for the mountain bike. So here's the rule. Taking a percentage of something translates into multiplying, right? Remember that from chapter 3 fractions. So you take that percentage times something. Of means multiply. I want 8% of 420. So I'm going to look at this percentage in 3 different ways. All right. First of all, as a percentage, that's how we write it, 8%. As a decimal, 8 over 100. You can put that in your calculator, but you should know that that's just an 8 in the hundredth place, 0.08. And as a fraction reduced, you have 8 over 100. I can divide the numerator by 4 and the denominator by 4 and get 2 over 25. Or you could have done it by 2's, right? Divide by 2 and then divide by 2 again. So 8%, 0.08, and 2 over 25 are all different representations of the same number. Right? So we're going to use the number line to find 2/25ths of 420. And then we'll use the number line to find 8% of 420. So here's our number line, and here's 25ths. So 25 25ths would be the whole, which in this case would be $420, right? And here is from chapter 3 how to do it, right? 420 times 2 over 25. So using a number line, I'm going to take 420 and divide it by 25. So I can, because it's a combination of multiplication and division, when you multiply by a fraction, I can do either one first because multiplication and division are tied. So 420 divided by 25, go to my calculator, and I get 16.8. Now I'm going to double that, or multiply it by 2. So that would be 16.8 times 2 is 33.6. So it's $33.60 is 2/25 of 420. So let's do it now with a percentage. I'm going to find 8% of 420. So I'm going to take 420 and divide it by 100. I'm going to get 4.2. And then I'm going to multiply it by 8. You can put it on your calculator. 4.2 times 8 is 33.6. So I get 4.2, that's 1%. And multiply it by 8, I get 8%. So it's $33.60. So the total bike would be 420 plus 33.60, which would be 453.60. So if you're trying to find a percent of something, it's multiplying. You do it on your calculator. I just wanted to show you this. Okay, we're going to go back to our bursts. And now we don't have this column filled out. But what we're going to do for 30 to 34-year-olds, we're going to try to find this number, which is how many bursts and the number of actual bursts that were attributed to 30 to 34-year-olds. And you noticed I did improve the accuracy here so that it's a very accurate number, right? And it's really difficult to work with pen and paper, but with Excel it's very easy because Excel is going to keep just dozens of digits beyond the whole number. Even though you don't see them, they're still there. They don't disappear. So with Excel, you might display that as 27.5%. That's how you display it, but it's really not rounding because in Excel it keeps all these digits down here hidden but still there. But for the purposes of what we're doing, I'll use 27.5%. So let's go back to, we know the ratio they were given, it's 27.5 out of 100, because that's what this means, this column here. That's the percent of bursts in each age category. So that's sort of like the total. You could say of every 100 bursts, 27.5% of them, 27.5 of them can be attributed to 30 to 34-year-olds. So that's part the total. I'm trying to find out how many actual bursts there are in the red box there, and I know the total number of bursts. So I'm going to cross multiply and divide and see if you can come up with the same number that I do, which is going to be a rounded number because I'm using a rounded 27.5. And if you did it right, you should get this answer. Notice I rounded to the nearest whole number because you can't have partial births. You either have a birth or you don't. And while ratios can have decimals in them, the number of births cannot. Okay. Okay, so I'm going to look at 1 and 2 here. 1 is extremely simple, so please do not get confused. It always means the same thing. A percent means per 100, whatever that is per 100. So that's 6 out of 100. You can have more than 100% of some things. This is 200 over 100. I'll just give you an example. One if I had a 2,000 calorie per day diet and I ate 4,000 calories. What percent of my daily intake of calories did I have? Well, it's going to be 200. So, and here's one here. It is what it is. It's 0.09 over 100. It's always the same thing, so don't get confused. So write 5/8 as a decimal and a percentage. So as a decimal, put it in your calculator, 5 divided by 8, and you should get 0.625. And as a percentage, you could do it several ways. Well, if you have 0.625, that's 0.625 over 1. If you multiply the numerator by 100 and the denominator by 100, you're not changing the basic relationship, and you're going to get 62.5 over 100. The other way you could do it is you could say 5 is to 8 as what number is to 100, and cross multiply and divide. You'll get the same thing. So 5/8 of 240, multiply 240 by 5/8 and its equivalent in decimals and percentage notation from above, okay? So 5/8 times 240 is 150. So 0.625 times 240 is 150. And 62.5%, which means 62.5 over 100, times 240, you better get 150. You're not multiplying by 62.5. That would be ridiculous. You're multiplying by this. So I want to do one of these questions on number 5. And what it says here is that here's your test. Maybe use blue here. Here's your test. This is the number correct out of the number of questions. And you want to change that into a percentage. Now I'll show you 2 ways to do this. The first way, you should probably 42 correct out of 60 total equals how many correct if there was 100 total. Cross multiply and divide. Okay? And you should know how to do that. The other way is just to go 42 correct out of 60 and just divide that. And you're going to get some number over 1. And let's put that in our calculators. And I'm getting 0.7. 0.7 over 1. So then you can either in your head or on paper move the decimal 2 places. So this number, and this number are all equivalent. So we'll get you started on this one. This is the total amount of people in the state, the population. I'll do Florida. We want to find the number that live in poverty. So I'm going to put that number right here. We know that the percent in poverty is 16.2. So that means that there's 16.2 living in poverty in Florida for every 100 Floridians. And we're going to find out how many people live in poverty if there are, and notice here that that's 20,071 population, but it in thousands, so you can either put it in your calculator, multiply it by 1,000, or realize that adding 3 zeros accomplishes the same thing. So now we can cross multiply and divide and put the actual number in here, which will be about, somewhere around 4 million. So I just want to go over how you could do these in your head. You could put them on your calculator, but it's easier actually to do them in your head. So 10% means 1 out of 10, right? Or 10 out of 100, which is 1 out of 10. So 1/10 of 90 is the same thing as 90 divided by 10, which is 9. So that would be 9. Well, if 10% is 90, 18 would, if 10% of 90 is 9, then 20% would be 18, right? That's just half of that number. So think about it that way. Okay, so here we're going to look at that again. We're going to look at poverty levels, number of people living in poverty, and we're given a rate per 1,000 instead of a percentage. So these are the different levels of education and the corresponding number of people that represents and the rate living in poverty. And I think you can see that as you have more education, that the rate goes down, especially nowadays. Okay, so I'm going to figure out this number right here, or just help you get started, right? So I have 306 people living in poverty for every 1,000 people with a high school education. So that's equal to, I don't know how many people living in poverty, for 23.5 million, which would be 23.5 times 10 raised to the 6th power. So now you can just cross multiply and divide. Remember, 10 to the 6th is millions, 10 to the 3rd is thousands, 10 to the 6th is millions, 10 to the 9th is billions, and 10 to the 12th is trillions. And I have to use this rate, 306. I don't have a percentage. I could turn 306 over 1,000 into a number with the bottom number 100, which would just be dividing by 10. I could use 30.6 per 100 is the same as 306 per 1,000. So that's how you could do those.